It's I figured it was my kids unplugged me or something like that. So who knows? So anyway, so great technology. We are long duration. We can do 4. We can go to 12 hours. Anywhere in between and really longer. And we do see the market asking for longer duration storage. And not only that, longer duration storage that can last longer, right? These are not 5-year contracts. These are 15, 20, 25-year contracts. And so our technology fits into that well. Again, we're a zinc electrolyte base. We're a sealed system. We don't evaporate. Some of the great things is we cannot catch on fire. So we don't need HVAC. Which eliminates the need for an HVAC system and all that auxiliary load, which starts to add up over years. And then we're non-flammable as well, so we don't need any fire suppression system and all the things that go with that. Designed in Edison, New Jersey, exit 10 off the New Jersey Turnpike. If anybody refers to their travels by the Turnpike exits, some of us East Coasters do. And we manufacture out in Pittsburgh, which I'll show you a little bit of that next. So. NASDAQ company and have we've got close to 1 gigawatt hour in the field, and that keeps growing. So I want to hit a little bit on our manufacturing here. So this is an aerial picture of our facility in Turtle Creek, Pennsylvania, which is really a suburb of Pittsburgh. Turtle Creek sounds pretty. Pittsburgh, well, not that it doesn't sound pretty, but it's a nice little town on the east side of Pittsburgh. Just a sort of a cool factoid here is this building was George Westinghouse's original manufacturing facility back in the 18 whatever it was when he was making his original electrical equipment. So it's kind of a nice full circle of manufacturing for the electricity markets over 150 years. See a little bit about what we're doing on the inside. I'm going to have Dana hit on a little bit of a higher level on this, but the main product that was going out the door in 2022 was our 2.3 version, which again was very simple, the same chemistry we started with, but the manufacturability of it was much better. But that allowed us to really grow. And so we took an empty building and then scaled it up in 9 months to really be able to start getting megawatts out the door. That is a repeatable process. So as we start to get more volume, the fact that what we use are, they're fairly easy minerals and chemicals to source. We can source them locally. We can source them all inside the United States. And then it's standard manufacturing line. We don't need very sophisticated clean rooms and things like that, like others, in order to continue to grow our volume. And you can see on the right side of the screen here is Z3, which is really the workhorse, what we're going to see going out the door in the next few years. And I'll let Dana really explain the value of that and the efficiency and why that's better when we talk about the product. But you can see, we're filling the products with our aqueous solution. We seal them, we weld the tops on, we test them, and we get those going out the door. So this is not these are not slides on how we're going to do it. These are slides on what we're doing today and getting product out the door, which is exciting. Just to highlight, we do love having guests. So we have a lot of our potential customers, our existing customers come to the factory. They bring consultants or whatever it may be to see what we're doing, to touch it, to feel it, to smell it, to make sure that we are actually doing what we say we're going to do. We were proud to have the DOE out last fall. The DOE is a good partner of EOS. There was a global clean energy action forum in Pittsburgh. Didn't have anything to do with EOS per se, but it was in Pittsburgh. There was 21 countries that came out to it, and then we were proud to host the DOE and a lot of other people at our factory to show them really what's going on in the United States. We're manufacturing energy storage. We're providing jobs, and we're doing what the country wants to do. You see this through, the Inflation Reduction Act. This was a terrific surprise for EOS because we were manufacturing. Listen, we started in 2008, way before the IRA was even considered. There was no ITC for storage unless you paired it with PV, and most people probably know that. The Inflation Reduction Act was a huge plus for us and a great surprise and a great win for the United States. But we fully qualify as a U.S. made product. And what does that mean for everybody? It means if you're monetizing investment tax credit, which is obviously a big deal in the United States for energy storage and renewable energy, we qualify for the additional 10%. Traditional energy storage manufactured outside gets the 30%, and then we qualify for the 40%. There's labor requirements and there's things like that, but all things being equal, we get an extra 10%. And when you start to look at those numbers, they're significant. It increases your internal rate of return by 1 to 3% or even more, depending on where you're starting, your cost of capital, and a lot of things like that. But what allows for project financiers to do is their money goes farther. If you get a higher ITC, you need less equity. When you have a higher return, you can take more debt on a project and leverage it. Again, less equity then because you're using debt, and you get a higher return. So it's really helped our project developers and financiers get a better return in an environment that's tough right now, right? Supply chain's tough, transformers cost a lot, interconnections cost more. A lot of forces are pushing against developers. Well, this has helped levelize that a little bit, and as some of these sort of peaks of supply change, you're going to see even greater returns because of the ITC. So it's a great win for EOS, and it's also, it just makes us proud that we're manufacturing in the United States. Probably the last point on that is you see more and more RFPs from government entities or utility entities that are requiring U.S. made product, and so we certainly fit into that bucket. So that's a little bit on just the high level picture of EOS, which is really what we're given today. Dana's going to talk a little bit more about the technology and why we are who we are and why we're great, and we'll go from there.
Yeah, thanks, Andy. Hello, everyone. Thank you for tuning in to learn about EOS. So I'm going to cover a lot of what Andy's already said. We'll go through the technology and product in more detail. And so, like Andy said, we've had a circular economy in mind since we've founded the company back in 2008. And most of the companies come from other parts of the renewable development industry. So we're very familiar with lithium ion project development, things like that. So we try to address a lot of the pain points that the utility scale battery storage market has faced since it's really become relevant. So first off, our raw materials. We have 5 main commodity materials that we use. They're widely available. They're also no conflict minerals. So a big difference between us and other battery chemistries. So we have much more stability and certainty in our supply chain, so we're not as exposed to big price swings in commodity materials as some other chemistries may be. Manufacturing, Andy covered it very well. So we have a much simpler manufacturing process. Not to say that it is simple itself. It's a big challenge, but it's much simpler compared to other chemistries. Now you basically just need a warehouse, overhead cranes, and we can get a multi-100 megawatt hour line up and running in less than 6 months. And those are very repeatable lines. So that's a very big challenge and something we've been working towards, in particular the last 3 years. So it's those pictures from Turtle Creek are a huge success for the company. More to that, we consume a lot less energy in our manufacturing process, and you'll see we've had some third parties validate not just that, but our supply chain, our product, our operations in terms of GHG emissions, and we have a big improvement compared to other battery chemistries, which we'll get to in a second here. The other part is our battery itself is a very thermally stable chemistry. So we're zinc-based chemistry. However, we're a static sealed bipolar cell. So we're not a flow chemistry, and we're not zinc air. So that is a key difference between us and some historic zinc chemistry batteries. But our system is non-combustible. It's water-based, and it doesn't really generate a lot of heat when cycling. So we do not require fire suppression. We do not require HVAC, and therefore have a much simpler system design, and consume a lot less energy to run our systems, right? Auxiliary power can be a big cost on project developers. So that's another big way that we cut down on emissions, is through the operations of our system itself. And then finally, end of life. Our system is fully recyclable by standard commercial recyclers. So There's no, toxic minerals or anything like that where you need a specialist to recycle this. Any commercial recycler can handle it. And so it's, remove some of the burden for developers at the end of life and trying to figure out the costs of, restoring a site at 20 years in the future, right? With us, it's a much simpler equation.
Yeah, and as you see more decommissioning bonds, it's easy to support the values in those bonds that are required.
Yeah. Yeah, and so here's a picture of a couple generations of modules that we have. So Gen 2.3 is what we've been shipping for the last 2 years. That's what's out in the field. That's in operation or being commissioned as we speak. The Z3 module is what we're working through right now. And that's, the future product. That's what we're launching this year. And that's going to be what our factory produces going forward. Our factories, I should say. And like we said, static sealed bipolar cells. So what you see, those are fully sealed modules. There's no pumping of electrolyte in and out. It's not open to the atmosphere, so you don't have electrolyte evaporation. So it's a very simple tub design. And we are a long duration battery, and for us that means anywhere from 4 to 12 hours is optimal. And that's what the graph on the right is emphasizing, is that the longer the duration, the better we are. And so those are the markets we're really addressing. We're competitive in 4 hours, and then we're seeing more and more activity in the longer than 4 hour duration market as the energy market gets more mature. And so this is our system design. It's a very, like we're saying, it's a very simple system design. There's the modules which we've seen, a DC battery cabinet, which has our battery modules racked, cabled inside of it, and then just auxiliary fans on the roof. And that's what vents out of the top there, pulls in air from the side. So it's a very, very simple system design. Not a lot can go wrong. And if it does, it's very easy to fix. So you can take those cabinets, directly parallel them together through DC bus bars. And then what's not pictured is a centralized control cabinet. So it's an Achilles heel of non-lithiums is that they take up a lot of space and they require a massive installation cost. So with this system size or system design, we've dramatically cut down on our install cost to be almost equivalent to lithium ion. So it's a big advantage for us. And this we'll go quickly through. This was the third-party report from Boundless, where they studied the whole company, right? You can see product, water consumption, all sorts of stuff, operations of the system, and compared us to other battery technologies. So we keep going back to lithium because they're the biggest in the market today, and we're from a GHG perspective 84% lower than a lithium ion battery. So we're very proud of that.
Yeah.
And then
last slide, guys, because we have some questions for you too before we move on to Vikram.
Sure. Yeah, this is the last slide here. So it's just third-party validation is always key. So we've had DNV validate us. We have certifications from UL. We've gone through all the rigor that every battery system has to go through. We've completed.
So thank you, Dana and Andrew. So if you go back to the 2 slides to showing the footprint of your technology up right here. So we get asked a lot. So that the 5 enclosures are 1 container. And what's your, is this megawatts, is this kilowatt hour? What's your capacity right here?
Yeah, it's megawatt hours. So we're always an energy battery that we're built for energy. So that's about, and these are our conceptual designs. So we're working through different iterations of ways of arranging the cabinets, but the current one is about 3 megawatt hours in that space. So it's we're able to dramatically improve our energy density too, Julia, to your point.
Wonderful, thanks. And then if any of our audience would like to ask questions to Dana or Andrew or Vikram, please put them in the chat so we can answer them live for you. Just give a second while they come in. And then both of you said that your company's EOS has been around for over a decade.
Correct.
Yep.
2008. Yep.
That's right.
Okay.
Yep.
And I see a hand raised. It'd be much easier because I can't see all the hands raised. If you could type your question into the chat, that'd be awesome. Thanks. There we go. Okay, and then so here's a question for you. So you're already showing that you're scaling up what
Yeah.
are you, what is your next stage that you want to scale up to?
Yeah. So right now we're optimizing the Z3 module line, and those lines are repeatable, right? So our plant is already up to a gigawatt hour capacity, and we're looking to scale to multi-gigawatt hours at a single site, right? So if we get more sites, we can scale even faster. But so it's a gigawatt hour in 2023, and then multi-gigawatt hours thereon, basically from improving automation and then repeating lines within the facility.
Great, a couple more questions, but please keep them coming in because we can also answer them in the chat as Vikram presents. But so just to clarify, there's a, when you're saying 3 megawatt hour, you're saying 750 kilowatts.
Yeah, that's 4 hours, right? Yeah.
And then Dana, you said that you're cost competitive with lithium ion. What is the value proposition you can offer if not cost?
Yeah, I mean, it certainly comes down to use case, right? So we've seen a lot of customers prefer long duration use cases. So there's a number of technological advantages there. We can do simpler system designs when you go greater than 4 hours in discharge duration, not as heavy of a install and complexity in your software compared to basically trying to do a lithium ion system stretching it to 8 hours.
And degradation over a long period of time is very flat. It's a little bit in the beginning, but it's very flat. So the farther the term of your project, the better we look, because we have less auxiliary power, minimal degradation, and you don't need to come in and sort of repack it or recharge it or anything like that in the middle of the term.
And last question, you've also been asked about, since they're non-flammable and containerized, can they be stacked to achieve higher capacity on a space limited site?
Yeah, they can. So it's not this exact outdoor enclosure. We have a different enclosure, or really rack arrangement that we're looking at for stacking. It's a slightly smaller unit that can go up to at least 5 pi. We're going through seismic studies right now. Those will be mainly indoor. So if you have to have a prefabricated structure or an existing warehouse, those can go high. 5 seems to be the limit. We don't want to,
5.5. Okay.
Yeah.
And then what's the lifetime for one of the systems?
It's 20 years. It's design life. We can do long-term service agreements, performance guarantees up to 20 years.
And then I think you answered this, but I just want to make sure that how does the cost per kilowatt hour compare between a high power rate of 4 hours versus a low power rate of 8 hours?
Well, it's just dollars per kilowatt hour, so they're the same rate. It's just there's more kilowatt hours in the 8 hour system. But yeah, that's we're an energy battery, so we price everything on dollars per kilowatt hour. Great.
Well, keep the questions coming in because we're going to go to Vikram next, and then if you have additional time, we'll come back to everybody and open up the floor. But this is fantastic, and look forward to the ongoing dialogue. But thank you very much, both of you. Thank you, EOS. All right,
Yeah,
Vikram, I'll hand it over to you.
Excellent. Thanks very much, Julia. Can you hear me okay?
Yes, we can. Thanks.
Perfect. Awesome. Thank you for having me here today. Sorry I missed the introduction of this this webinar. Unfortunately, we just got hit by quite a large snowstorm out here in southwestern Ontario. So I was navigating a bit of the storm, but here on time and here safe. That's the most important part.
Good. Thanks. Glad you're here.
Awesome. Okay, so I'm just going to share my screen here. If someone can confirm that they're seeing this.
Yes.
Excellent. Okay, thanks very much. So welcome. My name is Vikram Bhatia. I'm the Chief of Staff here at e-Zinc. And e-Zinc is the lowest cost, long duration energy storage technology. So we define long duration a little bit different than EOS. So we're looking specifically in the 12 plus hour duration range. And really our solution is economical in the 12 to 100 hour range. We're really focusing on 24 to 48 hour duration range as our key target market, as I'll go into in a little bit here. So just a quick company snapshot. We're actually based in Toronto, Ontario, which may be evident by my snowstorm comment. We were founded about a decade ago. We actually just celebrated our 10-year anniversary. We are growing quite rapidly though. Over the last 6 months, we've just about doubled in size from about 30 to almost 70. I think it's actually beyond 70 FTEs right now on the backs of our Series A1 raise, which occurred towards the end of 2021 and into 2022. The most important part that I want to highlight on this slide actually is towards the bottom. We were actually very, very fortunate and very happy to have had our first in-field deployment in Q2 2022. I'll talk about that a little bit later, but that was a smaller pilot proof of concept system. As well, we have two projects that we're working on right now. The first of which is with Toyota Shusho, which is going to be a 10 kilowatt, 48-hour duration system at a wind farm in Western Texas. And then the second of which is a similar size system with the California Energy Commission, for which we won a $1.3 million solicitation a couple of years ago. So we're very excited for both of those projects on the horizon. So I'll talk a little bit about the challenge, but I think everyone here is largely aware of this. With rapid renewables growth comes undependable energy, and what we're seeing from a modeling standpoint is it's more than just the daily challenge, it's the multi-day challenge that we're trying to solve for here with long duration. So long duration energy storage is of course required on a scale that can go above the 12 and 24-hour plus duration. Now, our solution is zinc as an energy carrier. So our solution is a pioneering electrochemical cell, which physically uses zinc to metallize and store energy. What happens in our cell is energy flows through the top of the cell and charges the cell through our graphite charge cathodes and discharges through the bottom of our cell. Energy is actually stored in the middle of our cell in the zinc electrolyte. When energy comes in through the graphite charge cathodes, it causes a chemical reaction which causes zinc to precipitate out of the solution and settle to the bottom of the cell as metallized energy. When your load turns on and you actually need to draw power out of the cell, an air cathode exists at the bottom. You inject air into the cell itself. It causes a redox reaction, which turns the zinc back into free electrons, turns the zinc back into solution, and then free electrons can flow out through the bottom of the cell as energy and power. So the solution of zinc as an energy carrier has a few different positive advantages to it. The first is it has a very, very low capital cost. We have the ability to be what's called a materials-based provider. So we can actually scale energy capacity independently from power, meaning you have a fixed power component and then scale energy as you will based on only the materials that go into expanding our cells and then constituting the zinc and electrolyte formation inside it. Because of this, actually, we see that on a marginal basis, our cost can be up to 90% less than lithium-ion cost for energy capacity. As you can see here on the right-hand side, an example of how we can simply increase the belly section of the cell for increasing amounts of duration. So 24, 40, and 100-hour cells can use the exact same charge and discharge components, just have additional plastic, electrolyte, and zinc in them, which is very, very cheap. The advantage of this, of course, is that it's both a flexible and a scalable system. We can do both smaller residential, so on the kilowatt scale types of systems, as well as go all the way up to grid scale with more and more cells. And from an energy standpoint, we can right size the system for a 24, 48, or 100+ hour duration based on the customer application. There's many other competitive advantages to this kind of solution, some of which actually we saw with EOS. So number one is a long lifetime. The energy capacity retains 100% throughout the lifetime of the cell, which our commercial target is going to be 20 years. The cell has a large operating temperature and is being third-party verified to operate at temperatures as low as -30 degrees Celsius and up to +6 degrees Celsius. So again, perfect for the weather we're having here in Canada now, where it's not too cold but snowy, and it definitely gets very hot in the summer. The cell itself is fire resistant. Of course, it's sitting within a liquid electrolyte, so there's no chance of thermal runaway. And in any case, actually, the slight temperature rise associated with both the charge and discharge cycle of our cell are both advantageous at our cells, more effective at slightly higher temperatures. Finally, the entire cell is recyclable and reusable. So parts that we use as part of our cell can be deconstructed and recycled. And actually, physically, the zinc inside of the cell can actually be reused in other cells as we need to literally transfer from one to another. So we intend actually, when we go to market, for cells to go to customers for 5 or 10 or up to 20 years, and then when they hit end of life, come back to the facility, be refurbished, and then be able to be reused for a second use. Oh, sorry. So e-Zinc has received many different recognitions and awards over time. We are actually part of the 2022 Global Clean Tech 100, and this needs to be updated because we're now actually being announced as 2023 as well. So we're very excited about that. James is at the Clean Tech Forum right now. We've been featured in both Green Tech Media and BNN Bloomberg. We were awarded the $1.6 million grand prize through Breakthrough Energy Solutions Canada through NRCan, through NRC a few years ago. As I mentioned before, received a $1.3 million solicitation through the CEC, as well as we are Impact Canada's Charging the Future grand prize winner, which was announced around this time last year for $1 million Canadian. We have a number of high value investors as part of our portfolio. So Energy Foundry was our Series A major investor. They're a deep science and energy focused firm out of Chicago. BDC, of course, is Canada's largest venture bank. Anzu Partners out of San Diego and Cambridge are, again, Series A lead investor with a deep science and technology background. But the two we're most excited about actually are the two on the right here, which are Toyota Ventures, which everyone I'm sure has heard of, as well as AnyNext, which is one of the global super major oil and gas companies. Both of these investors were brought on as strategics in our Series A for specific input into our products and company. Toyota Ventures were focusing their support on supply chain manufacturing and commercial pilots downstream. AnyNext is also helping us with downstream pilots commercialization, by giving us specific support on R&D as we look to develop our technology and bring it to the next level. So to think a little bit about the market opportunity here, again, I don't need to give everyone too much of a lesson, but what we're seeing as a market from a power and duration standpoint, flywheels and capacitors are great for that very high power but short duration kind of time span. Batteries and flow batteries we see kind of coming right next to that in terms of shorter duration in that 4 to 8 up to 12 hour kind of range, and again can go very high power. Pumped hydro and compressed air are great for, again, very high power, longer duration, but sometimes need specific geographies and only are good for specific projects. But what we really see in the middle is a big white space in which there really is no economical energy storage solution. And that's where e-Zinc really pipes in here. I know many of you on the call will be familiar with other solutions, which I'm sure you think are solutions here as well. Not saying that's not the case, that's not mutually exclusive, but we do believe that e-Zinc has a great solution for the multi-day 1 kilowatt to 10 megawatt power range. And that actually is going to be our initial target market here. We're specifically targeting small to mid scale, so less than 10 megawatt and long duration over 10 hour kind of applications. And initially we intend to go there via the resilience or backup power and remote power market, which today are often served by diesel generators. So I'm going to talk about the markets in a little bit more detail here before we move on to questions. So from the resilience and remote markets overall, we see energy storage in the future as being a $100 billion market. Remote and resiliency, of course, which a smaller part of that is about 20 billion. e-Zinc is going to have a phased go-to-market approach. So in our Horizon 1 market, which we're actively looking at pilots right now to be deploying in the next couple of years, we'll be having Horizon 1 resilience or backup power systems and non-wire alternatives. And then in Horizon 2, which will be towards the 2025 range, will be more for remote applications, so non-grid connected. So we're thinking off-grid residences, remote communities, mining operations, those which either have very intermittent or no grid connection at all, largely to buoy renewables and work even sometimes with diesel generators to support operations. Our long-term goal, like many folks here, of course, is Horizon 3, 100% renewables for renewables firming, and sometimes even up to seasonal storage as well where applicable. So I'm going to talk a little bit more about our Horizon 1 use case, because I think that's very relevant to many people on the call here. So the benefits of the e-Zinc technology is twofold. Not only does it give you the energy benefits associated with daily cycling, time of use arbitrage, et cetera, but can also give you that increased resiliency. So in areas such as California, which are sometimes hit with 12 or 24 or even 48 plus hour public safety power shutdown events, e-Zinc system can not only act as that energy buffer for day-to-day cycling, but also the longer term outage play as well. On top of that, of course, it's totally clean and it reduces greenhouse gas emissions. So this example showcases, the impact of our system here in California. This dark line in the middle here, actually you can't see my house, can you? This dark line in the middle here is actually going to be the load of the system. And then the dotted line over here is the battery state of charge. You can see that at times of high load, largely you have solar that is going to be supplying in the beginning part of that peak, whereas the excess solar will be going directly towards charging the battery. And then high peak times, such as in the evening, you can have the load power directly off the charge itself. During off-peak times, when you have lower indications here, for example, is when you have both the battery state of charge going up due to charging at lower power, at lower time of use prices. But also you can use the grid to directly power your own load itself. Julia, are you gonna pop in here for a second?
I am. I was just going to say, Vikram, do you have one more slide? Because we need to go. There are a lot of questions for you. So I want to move to questions.
Oh, great. Yep, I can definitely go to this slide, which seems like a good slide to end on. So in summary, we have, again, a breakthrough technology. We're in the first world to really metalize electricity. Global patent protection in many different jurisdictions. Again, we have 7 patent families. A unique value proposition which can serve white space in a large market across a number of different flexible and scalable applications. Demonstrated market pull. So we have partnerships that are ongoing right now, as well as strong partners in Toyota, AnyNext, and the CEC. And here's my contact info if you want to ask me any questions offline.
Thank you, Vikram. So is there any particular use case operation profile that you expect to give a larger advantage versus lithium ion?
So specifically with lithium ion, actually, we think we can, again, kind of serve both markets in terms of providing that daily cycling as well as having that backup power. So thinking about commercial industrial applications, which are, I would say, like small manufacturing operations, apartment buildings, even going up to, as we get to uninterrupted power, hospitals, for example. These are areas in which, our system can not only replace a lithium ion battery at a lower cost, but also provide resilience as well.
And there's 2 questions on climate. So do the enclosures have climate control, and does the electrolyte freeze below -30 degrees Fahrenheit?
So on climate control, actually, no, we don't actually need climate control because the ambient temperature our systems operate is only a few degrees above room temperature. So no climate control is actually needed for the cells. Actually, there's a couple of mock-ups I could be able to show here where our cells would be shipped in shipping containers, very similar to how EOS showed. We do have some venting there, but you'll actually note that those shipping containers are painted black because the increased temperature, as I mentioned, actually helps our efficiency. And then the other question was on electrolyte freezing. No, it is a saline solution, so no, it doesn't freeze below freezing.
Great. And then there's what about, you mentioned round trip efficiency, but what is it for your e-Zinc batteries?
So our commercial target round trip efficiency will be between 55 and 60%.
And then do you have a cost target for the 48-hour duration model?
So our cost targets, unfortunately, I'm unable to share the exact targets we have right now, but something I can share is that we will be extremely competitive with lithium ion and other sorts of longer duration energy storage on a marginal energy storage capacity, particularly beyond the 24-hour range.
Great. And then I'm curious about this because I don't know. Does your technology have the issue of dendrite formation?
Yes, actually, that's how actually the zinc is formed inside the cell. It is zinc dendrites that do form, but then those dendrites are actually recirculated back into the system when discharge occurs, and those dendrites then turn back into an aqueous solution. So yes, there are dendrites formed, but that's kind of what we want.
Yeah, it's a good thing. Yeah. And then so this I'll ask this to both you and to EOS too. That there's questions about the wholesale markets, and how do you see the long duration energy storage having a high profitability without a utility or a state contract in place?
Yeah, that's a great question. I'll definitely answer our side of that first. So we definitely see e-Zinc having a strong play with remote communities, with large operations such as mining, for example. So we see longer duration being critical in these applications where, in an area like Chile, for example, which has very high solar and has a need for on-site long duration energy storage, we certainly see large contracts that can be procured for companies such as this to support our own commercialization.
Yeah, and I'll add a couple on that. I mean, we see longer duration needed for firming wind and solar as as more wind and solar are being required to deliver, consistent capacity or there's liquidated damages around that, you need to be able to firm it, and not for 1 or 2 hours. You need to be able to firm it, for 4, 5, 6, 7, 8, 10 hours. And so we see a strong market application there, and you're starting to just see it more and more in the US. We're seeing our product going to firming large solar farms and wind and things like that. And then if you also look at coincident capacity and capacity, that's where, ISOs have, their peak load contribution or coincident capacities. Up in Canada, they have the global adjustment charge. That you used to be able to hit that in an hour or two because you'd see the ISO peak. Now those peaks are getting smoother and longer. So in order to hit those, which are really financially strong, they can be anywhere from 50 to 100,000s of megawatt year. You need 6, 7, 8 hours to capture those and be sure you're going to capture those. And there's a lot of other examples. Microgrids are a great one that Vikram put out there, but it's just, you just see more and more need for longer duration of consistent power.
Well said. No, thank you both very much. So for Vikram, and then I'm going to come back to you, Andrew, on one too. So there was just a clarifying question for your business model: grid scale or CI or both?
Yeah. So sorry, was that to me first, Julia?
Yes.
Yeah, perfect. So actually, we definitely see both. As I kind of mentioned, we are gonna have a phased market approach here. We do see our commercialization path in the next several years being largely C&I focused as we build towards A, grid scale capacity from a manufacturing standpoint, and B, grid scale projects and customers from that standpoint as well. And the third thing, of course, is how the market evolves, right? We're not really seeing on the market right now those really large calls for 12 or 24-hour plus duration at utility scale. So once we want to set ourselves up to kind of slow ramp that, so when those calls do come out, we're prepared to hit them.
Great.
And for EOS, same story, right? We're C&I and grid scale. The only thing we're not is residential. We're not well suited for, but grid scale and C&I, yep.
Which is interesting. If you look at the New York State energy storage roadmap they just piled out, I believe 64% is utility scale, 32% is C&I, and 4% is residential. So we just missed 4% of the market, I suppose, as of today. But
As of today.
Right.
unless it's a really big house, we might.
Yeah. They're okay with shipping containers in their backyard. Then they're good.
And so speaking of shipping containers and scaling up, what does EOS currently see as the largest hurdle to large scale production?
That's a good one. I mean, it's certainly getting more buying power in our supply chain as we continue to ramp. We think customer need is there, right? We're getting been able to get a massive amount of booked orders in a short amount of time, and I think that will continue. And so it's really just scaling up, getting more control, more weight in our supply chain, and then being able to get capital and continue to scale. Andy,
yeah, I mean, Dan is ready. And hopefully, the tough part out there is you look at like what's going on PJM and some of these other interconnection queues, projects are there. They just need to be, people they want to take delivery, but there's just, there's some technical hurdles holding them up. So I think queue reform and things like that and getting better interconnection flow is going to have a large impact on us getting product out the door.
Right. Just understanding all the criteria, the value out of the ancillary services, long duration energy storage technologies can give to the grid and behind the meter, I think is going to be a big educational component. And as we justify the need and demonstrate this with data more, it's going to really help.
I agree, but I think, it's the people are getting educated very quickly. Like if you had this conversation 18 months ago, it was different, right? So
yeah, true. No, that's great. And that's why we have such a great attendance today with people wanting to ask good questions. So keep them coming. For Vikram, do you have a pilot plant in operation?
So right now we're actually manufacturing at what I would call a prototype stage. We actually have our pilot plant that is being rolled out in about 6 months time or so. That's going to be a 50,000 square foot facility in Mississauga, Ontario, which is just outside of Toronto. So not quite yet, but looking forward to opening that and breaking ground in about 6 months or so.
Great. Now we can look forward to the next stories and next steps of seeing the products grow. And so for both of you, as you're working with different clients and customers, from your product, but also from installed sites, what feedback can you share with the group?
Yeah, I mean, for us, for EOS is who we're selling to is primary developers who only have ever used lithium ion, right? So it's always us versus lithium ion, and a lot of the new system design was around their feedback, right? Oh, zinc takes up too much space. Oh, you have high install costs, things like that. And so that's where really our new system design came out of. It's been focused on install cost, ease of installation too. So making it customer friendly is a big piece, and I think we're really able to do that with our latest product.
What's also been interesting to watch just the evolutions of both of your products going from, the 4 to 8 to 100-hour or to the, the new generation of the capacity. I mean, it just in a short amount of time, you're already seeing, because of customer feedback and the dialogue that we're having, just that improvements that have been happening, as quickly as we can, just so we can make sure we can scale up. So it is quite impressive just to see the changes in the last 18 months from both of your companies.
Thank you.
Then here's a great question for everyone, because we've been working on this also with the councils, is how to really help work with the governments around the world, because we are global and cover over 20 countries with our membership. And we're working in different markets trying to, again, accelerate the scaling up of LDES. What kind of policy support do we see? And, we have a public policy report that we did with our members of a carbon price, these mandates and standards that you see promoting renewables integrations and promoting, the procurement of long duration energy storage. There are 9 states in the US that have storage targets. That's a great starting point, but they need to be, 50, 100, 200 megawatts, every year that we're scaling up. So those are some I'll throw out there, but in particular to Vikram and Dan and Andrew, what additional ones would you like to see?
I mean, from our standpoint, the IRA was such a great thing to see from an energy storage standpoint, and calls for long duration as well. We're encouraging. We're looking at having the same thing in Canada as well. So Canada did announce that they would have an IRA-like device, the details of which are currently in consultation and haven't been released yet. But that's what we really need to see from our standpoint to continue our operations here is really have that support for domestic manufacturing to deploy larger scale pilots with utility scale customers.
Yeah, and you'll probably see that happen globally, right? I mean, one of the things about storage, ours or anybody's, it's heavy, right? Shipping it is not, localized manufacturing is going to be more beneficial. You sort of make the parallel to the cement industry or something like that. And so if you see more incentives to manufacture globally, it'd be great. But with that said, we see global interest in what we're doing. So I think it's our job to fulfill it and to perform. So the people that are sort of stepping out on a limb and offering these incentives and looking at new technology will, we do what we say we're going to do, and that will grow us, organically that way. So I think it's, we've been given a lot of gifts with the IRA and other things. We got to act on them and we got to perform, and that'll really help us grow.
Well said, all of you. Go
I was
ahead.
gonna say, I agree with everybody, Vikram too. The IRA was a huge win for the industry. The only point I'd add is, more incentives for particularly long duration storage to help further integrate renewables with the grid. We're not 1 or 2% renewables, but 10, 20%.
I mean, we really do see enormous value add with the price coming down and the emissions coming down at a 60% penetration of renewable energy, and that really essential need we have for the energy shifting of meeting every hour of every day and making sure that you have clean energy, and how long duration energy storage does make that happen, and then having the right policies in place to really validate this is critical. So we have the maps, we have the tools, it's now implementing it and working together. I think it's a very healthy competition and collaboration among the countries pushing for this, because we all have net zero target goals. We all have to meet this global demand and need. And I think that's what's also exciting to see much more collaboration, identifying, supply chain concerns and really just bringing LDES into the conversations as part of the solution. So it's a very exciting time. And again, we appreciate everyone being here today. There's a couple more questions coming back. So zinc has so much more promise, but sometimes gets lost behind the more overhyped battery technologies. What is needed to get the public and government excited about the clean, sustainable potential of zinc batteries? Someone really loves zinc. That's great.
Yeah, that's good. It's I don't know. I mean, there's a look, EVs are going to take something like 95, 98% of lithium, right? And it works, right? It's compressed and all that. I don't know. I think it's just a general education on storage will start to come around. That'll help. And that, you don't need super compact storage everywhere, right? When you're putting zinc on PV farms, space is irrelevant. And by the way, we don't take up that much more space than lithium, but I think we're just being compared against the first mover that's being used for multiple things, right? Your phones, your cars, and things where you need really dense power and you need to dispatch fast and things like that. So we're just being compared against the first mover that has, it's not always our market necessarily, it's other markets. So
And I couldn't agree more. When I see customers send us test procedures that the utility is making them meet, they're all written for lithium ion, right? Just because lithium ion was there first. And so you have an industry built around one battery technology, when now there's a whole suite of battery technologies, each with unique advantages. But the test procedures, policy, all that is written around lithium ion. So it kind of models, even customers' models are all lithium ion. So I think just, yeah, education is key. Getting people to look at battery is not a single type of battery, but a suite of batteries.
Diversity is essential.
Yeah.
Thanks. And Dana, there's a clarifying question for you too. It says, maybe it's semantics, but if you were truly optimizing for 8 hours, you could cut some of the costs in the cell, maybe thinner current collectors, but would you no longer be able to charge discharge at the 4-hour rate?
No, I see what you're saying. Yeah, you could cut costs in other areas. So for EOS, we manufacture the DC system. But you're absolutely right. You could cut costs on inverters with an 8-hour duration. You can cut costs on install cost for an 8-hour duration. That part is true. For our system, no, I mean, we can't reduce our current collectors within our units. Those are all, certified to UL, but you're right. You would see cost savings elsewhere in the project, like PCS arrangements.
And time always flies when you're having fun, but I would like all three of you to just kind of leave on a note of what would you like the audience to know about EOS and e-Zinc and the future that's tomorrow that we need to do to make sure we're all buying this in the marketplace.
Yeah, I'll kick off a little bit. So let me just actually answer the question that was a couple of times ago, and the bankability question that's popped up here. What e-Zinc really needs is boots on the ground, right? We're really looking forward to getting out our next couple of pilots and really proving our technology at a larger scale. And what we need to do that is talent. Finding talent these days is not as easy as it seems, and it's really something that we're always trying to do. So if anyone is interested, has an interest in zinc as a technology or helping commercialize it, feel free to reach out. We're always happy to hear from anyone. But really excited about the potential of our technology and really excited to open a new facility and start commercializing this thing.
Very cool. Thanks, Vikram.
Yeah, and for us, there's probably a lot of things, but I think we need to keep our foot on the gas. We're going in the right direction. It's been 15 years. Our chemistry, right, our manufacturing is doing well. We need to get more product out there. We need all of our customers to see the value of the ITC and the IRA, how it's doing, and we need to keep going down the road. And there'll be surprise turns as we go down there, but it's we're just going to keep pushing hard and growing and do it smart.
Yeah, and I totally agree with Vikram and Andy here. Only point I would add is continued support from policy, right? IRA was great, but seeing much more active investing in domestic manufacturing and growing out the supply chain here in the US as opposed to overseas.
No, thank you all very much, because this collaborative nature is so important, working together. The pie just needs to be made bigger for all of us to have that diversity to really kind of amplify the important role of LDES. And the funding that's coming from the government and state and federal private public partnerships is really important. Continue to push on the innovations that we're developing with LDES technology, and again getting the right policies in place so you can really see the enormous value add of the LDES technologies to perform on and off the grid and remote system. So we're looking forward to working with all of you. Again, the companies are growing, all looking for talent. So great point, Vikram, on making sure people know that there's a lot of growth opportunity here, and always looking for amazing individuals to join the LDES world. And again, we touch all sectors, so it's tons of opportunity. And Sumit, if you could just bring up the slides one more time. Again, I want to thank all the panelists. Thank you so much for really educating our audience more about EOS and e-Zinc and the benefits of zinc technology and how important it is to the diverse portfolio of LDES. And we have 4 reports that are on our website that really again highlight the important role of long duration energy storage and addressing public policy, 24/7 clean power purchase agreements, net zero heat and net zero power. It's a $4 trillion global market where LDES plays an essential role. And, you can get up to $540 billion a year in savings by bringing LDES into your system. And so, it's global numbers, but really, working with our local partners, really, again, honing in on how can LDES work with your community to provide the benefits. And you can reach us about, becoming a member, learning more about our partnerships, and then, follow us on social, because we continue to have these technology sessions. We have a lot of great webinars, outreach, and we're always promoting our members and all the great work they're doing and scaling up. So again, thank you all so much for joining us today. It's great to have you with us, and we'll be making sure that if you signed up, you'll get the presentation. So again, thank you very much,
Thank you.
Vikram, Andrew, and Dana. Thank you, Suman.
Thank you, everyone. Thanks, Julia.
Thanks,
Thank you all.
everyone. We appreciate
Thanks.
it.
Have a great day. Bye.
Bye.